Okay, welcome everyone. We are going to get started. I want to welcome you again to our 2020 Sustainable Food Systems Lecture Series hosted by the College of Agriculture and Natural Resources. My name is Meredith Epstein and I'm a senior lecturer in our Institute of Applied Agriculture, which is our 2-year academic certificate program in ag on campus. And you are also being hosted by a class that I'm running right now. So several of you want to say hello. You're in class right now, and we welcome everyone else who has joined us this evening, especially Rohan Tikakar, who is the co-chair of our Healthy Food Systems Strategic Initiative team, which has been very generous to support this lecture series this year. The Establish a Healthy Food System and Ensure Global Food and Nutritional Security Strategic Initiative is one of 5 that our college is championing and demonstrating our expertise in. For example, through this lecture series tonight. I also want to thank Brad Paleg for all of his excellent IT help. And I want to introduce to you our speaker tonight, Dr. John Erwin. He'll be speaking to us, as you can see, about opportunities to increase nutritional value, access, and safety through controlled environment agriculture in a changing climate. And I'm pretty sure I overheard him say that he wanted to make sure he wasn't going to blow a fuse, so you know that it's going to be a fun time. He's got some things that light up to show you tonight. Dr. Erwin earned his Bachelor of Science in Ornamental Horticulture from Delaware Valley College of Science and Agriculture, and his Master of Science and PhD in Horticulture from Michigan State University. John was a professor of Controlled Environment Agriculture in the Department of Horticultural Science at University of Minnesota until just this past October, when he uprooted and transplanted down here to Maryland, when he started working as the professor and chair of our Department of Plant Science and Landscape Architecture. He told me not to talk too much about him, so I guess I'll stop there. And because there are several acronyms about lighting that I don't understand in this bio, but I'll leave that to him. And he has a wonderful presentation for us tonight, full of wonderful pictures and a lot of excellent content. And we are going to hold questions for the end, or did we? Okay, we'll see. We will take a pause when he could invite questions from you, and we'll have time for Q&A at the end. So if you have a question that you'd like to ask, be sure to jot it down so we don't lose it in the mix.
You can raise your hand at any point. So if you have a question,
okay.
Raise your hand.
Okay, raise your hand, and that goes for our online audience as well. We do have several people who are accessing this through WebEx tonight. If you would like to ask a question, you can type it into the chat, and Brad here will make sure that your question is asked out loud. All right, thank you.
Thank you so much. I really appreciate the invitation here today. My name is John. As was mentioned, I'm from Southeast Pennsylvania and somehow came back around to the University of Maryland. The University of Maryland was actually the very first college I ever set foot on. And when I was 9 years old, I came on this campus. And so it's kind of interesting how it kind of worked out. So I just want to talk about controlled environment agriculture, which I think is one of the most exciting new parts of agriculture that's out there. And we're already helping produce a lot of these things. For instance, if you go into a Wegmans, a Lowe's, a Home Depot, a Trader Joe's, all of those stores now sell products that a faculty member at the University of Maryland helped produce. So we have a direct connection with all those places. Any succulent you see at Home Depot, all those racks, we help grow that. The basil at Trader Joe's, we help grow that as well. So I'm going to talk about the opportunities to increase food nutrition access and safety through controlled environment agriculture. It's a new area that's really growing rapidly. I'm going to show you why it's growing rapidly, because the recent advances have caused that. I'll say something about the University of Minnesota. I worked there for 30 years. There's another faculty member here, Yu Ping, who was there for quite some time as well. Great institution. Norman Borlaug was a faculty member there, the only plant scientist who got the Nobel Peace Prize for doing the Green Revolution. The football team is notoriously bad. Everyone beats us except this year, the year I leave. So we also produce Honeycrisp apples. So at this time of year, this is what's going on up there. So I'm happy to be here where things are blooming, because up there literally it snows until, I think there's a Prince song, When It Snows in April. Do you know that song? So it snows all the time. So controlled environment agriculture, it's not that new. Matter of fact, we used to do controlled environment agriculture all the time. This is a picture from a facility in Minneapolis called Bachman's. And in Minneapolis, we're a long ways from Florida and California. So to get fresh food, we had to grow food in that part of the country in greenhouses. It is the only way to get fresh food. And the greenhouses all switched over from those vegetable production facilities. There's actually pictures of horses with plows inside greenhouses back then, but they all switched over to ornamentals. What happened? What was the big thing that happened that caused this? Eisenhower did it. What did Eisenhower do?
I'm not going to say it.
Don't say it. Go get away. What did he do? He established something in the United States that made a huge difference. The interstate highway system. And he established it as a national defense priority because of the Autobahn, what he saw in World War II in Germany. So when the interstate highway system went in, all the vegetable production facilities in lots of parts of the country evaporated because you could get the vegetables from the fields in Florida and from California. However, things have come back in a huge way, and I'll talk about why this is. So these are lettuce produced on floating rafts, and underneath these lettuce plants are fish. So this is in Wisconsin. This is a picture of southern Spain to give you an idea of how big controlled environment agriculture has come back. I don't know if you can see that picture from the air. Those are all tomato greenhouses and pepper greenhouses, mostly built and run by the Dutch. So the Dutch used to do a lot of this work, of course, up in Holland, but they all moved to Spain. Why? Because it's warm and bright. And so as soon as the EU was formed, this started happening. So it's a huge effort. Okay. Why is some of this happening? Well, 50% of the world's population now lives in urban areas, and you'll see that that's projected to increase to 70% by 2030. So people want to be closer to their food, but there's also recognition, especially with the younger generation, that they would like to grow food sustainably. And an issue that we have is a lot of times when you get vegetables on your plate, many of those vegetables are from 1,500 miles away. So growing food closer to where you live is something that is a desirable thing, and I'll explain some of the reasons why, but also for social reasons, people like to do that because it's using less energy. Urban horticulture activities are increasing globally, and now an estimated 100 million people are involved in this effort. Okay, and of all the areas, vegetable yield appears to be the highest per square meter as far as kilograms per square meter per year. So that's what things have happened first. I would say that one other area, and not two other areas have increased greatly. Does anyone know what those are? Two other things that are increasing greatly in controlled environment ag. What two crops? Or two, one's a crop, one's not. Vegetables? Be something else? Yep.
Cannabis?
Nope. Or you want to talk about cannabis? I'll talk about cannabis later. Okay. Fruit, specifically strawberries. Okay. And the other thing is aquaculture. Aquaculture is technically controlled environment agriculture. Of course, the earth is warming, and we live primarily where the earth is warming. Now, warmer earth means certain things. It makes lots of crops have reduced yield. What does that mean? So in the US, each degree day that a maize crop exceeds 30 degrees Celsius, okay, yield is reduced by 1%. Okay, this is data from the FAO. In Africa, it's reduced by 1.7%. This is a single day over a 30 degree days, each degree over that. This is work I did back in Minnesota to show you some of the impact of this. So this is photosynthetically active radiation. So this is increasing light as we go from left to right, and it's photosynthesis on the y-axis. And you can see that as you increase light, if you look at the top line with the circles, photosynthesis goes up. But then what I did is I exposed the plants one day to 35 degrees Celsius, okay, which is approximately 95 degrees Fahrenheit. What happened to the rate of photosynthesis? The maximum rate dropped 59% all the way down to here. What was interesting was the next day, it was still depressed. The next day, it recovered somewhat. So one hot day, 95 degrees, which is not that hot, okay? Suppressed photosynthesis for nearly 3 days. Okay. This was New Guinean patients, but we also confirmed this with 4 other crops we looked at, including tomato. So these episodic events that are starting to happen are actually potentially having a larger impact on yield in some cases than a constant average temperature effect. And we're starting to really appreciate these episodic events play a role. I did work where you can see with flowering can be completely suppressed. This is Arabidopsis. You can see above 32C, the remarkable difference in lack of flowering when temperatures get too high. Now, this isn't important for leafy greens, but it is important for other stuff. Some of that work, we're able to show that there's an association with abscisic acid, which is a plant growth hormone. We're starting to, the plant growth hormone closes stomates. Do you remember what stomates are? The pores on the bottom of the leaf. So we're looking at heat tolerance being associated to either ABA synthesis in a plant or the response to ABA within the plant. But this has a huge effect on things like strawberries, where if you depress photosynthesis for 3 days or on a constant basis, you're going to dramatically reduce flowering, okay? And a strawberry is an aggregate fruit. So actually, when you look at a strawberry, all those seeds, each one of those is an individual fruit. And so the size of the strawberry can decrease dramatically if you reduce the flower size. This is a paper that stirred a lot of controversy in Nature in 2014. This was a comparison between ambient CO2, 400 parts per million, which is outside, and increasing CO2 levels up to 550 parts per million. And what this is different crops. And on the left, 0 means no change. So that's ambient CO2 outside. And you can see that if the CO2 levels increased, what happened to protein content of all these grains? It decreased. So the title of the paper is Rising CO2 Threatens Human Nutrition. Okay, so increasing CO2 is not always necessarily good. Okay, this is a little bit controversial. We also note this, we look at carotenes, which is a desirable nutrient in plants. And if we compare 20 degrees Celsius, which is 68 to 86 degrees Celsius, and we look at the total carotene, notice it goes from 78.9 to 14.1. So the hot temperatures can reduce the nutritional value of plants in some cases. So these different things are happening on the sidelines. I think they're impacting, in part, why people are interested in controlled environment agriculture. But I think the biggest issue and factor impacting controlled environment agriculture is human preference. Now, make no mistake, I think that eventually all agriculture is going to have to be controlled environment agriculture if we keep doing what we're doing. The world is getting hotter, there's episodic events. We have to grow this food in places where we can. Water shortages are causing this as well. We think of controlled environment agriculture only in terms of greenhouses, but if you go to a place like Saudi Arabia, they have completely enclosed warehouses where they're growing food inside, specifically to recirculate water, because water can be the limiting factor there. So public preference has changed. What's happening to public preference in the United States? So this is 2009 versus 2014 as far as fruit consumption. What's going up? Berries and bananas. What's going down? Orange juice, apple juice, berry juice. The juices are all going down. What about vegetables? What's going up? Carrot, spinach, avocado, kale. These are all going down. What's consistent between these? Almost all these vegetables, spinach, avocado, kale, berries, and bananas, there have been significant reports out there talking about the nutritional benefits of these crops that I think are impacting people's desire to eat them. If we look at a recent, 2018, Gallup came out with a poll. Most Americans try to include fruits and vegetables and avoid soda and sugar. So this is recently. So the green is that the percent of people that try to include them, 92% of people try to include vegetables in their diet. Okay. The black is avoid, 1%. 1% tries to avoid. Notice vegetables, fruits, chicken and other poultry, fish and seafood, and locally grown are all extremely high. 3 out of 4 people want to eat locally grown foods. What's interesting though is if you look, this is a recent in 2018 in the New York Times, most Americans' fruit is now imported. So you can see vegetable percent that's imported and also fruit that's imported. And this just recently exceeded 50%. So we actually are importing more fruit and vegetables from overseas. Why is this? Because we can't grow some of these things here. And so we want to have a kiwi fruit all year. We don't want it just when kiwi fruits would naturally be produced. Having said that, if we look at this paragraph, local food sales in the US grew from 5 billion to 12 billion between 2008 and 2014. According to food industry research, they expect that this is going to go up to 20 billion this year. Now that's huge. It's quadrupling. So I think some of the reason why we're getting stuff from overseas is because we're not able to produce it locally. So the only source of it is going to be overseas. But as we start to produce this product here in the United States, we can displace the imported material by growing things in controlled environments. Notice in 2016, venture capital funds made 66 food and beverage deals, up 20% from 2015 in a single year. So venture capital is flooding into controlled environment agriculture as well. So this is the first company I worked with in Minnesota. It was Bushel Blade Tomatoes. They almost went out of business. They almost went out of business until they added one word. What word do you think it was? Nope. Nope. Put Minnesota on it. When they added Minnesota above Bushel Boy, their sales went through the roof. Literally, they were about to go bankrupt until they added Minnesota above Bushel Boy. And that made a huge difference in their sales. Huge. The other thing, as I mentioned, is this. So this is a quote from Barbara Kingsolver. Each food item in a typical U.S. meal has traveled an average of 1,500 miles. If every citizen ate just one meal a week, any meal composed of locally and organically raised meats and produce, we would reduce our country's oil consumption by over 1.1 million barrels every week. That's Barbara Kingsolver. I don't know what data she's using for this, okay? But it does raise the question that a single meal a week could have a significant impact on oil dependency and oil consumption. And people are starting to market. This is a leaf. I'll show you some videos from this company afterwards. Nothing against California, but the greens are so 7 days ago. So they're marketing this in Boston because they're in New Hampshire and they sell to Boston. They have many of these. So every bag has a different saying on it, and they're all pretty cool and they're all a little bit funny. So their sales have been going through the roof as well. We did work when I was in Minnesota. I compared a conventional grocery store versus an organic co-op because I wanted to see if there were differences. Okay, so if we look, Cub Foods is something like Safeway here, okay, or Giant, and there's an organic co-op in my neighborhood, Seward Organic Co-op. I went down there and I got a mescaline mix and I sorted through it to pick the same species, the same material. But what was interesting was if you looked at the vitamin C content of the conventionally grown mescaline mix, it was 11.5 milligrams per 100 grams vitamin C, whereas Wedge, which was the organic co-op down the street from me, was 20.1, nearly double the vitamin C content. Now, to be honest, I raised my eyebrows a little bit because I thought all this organic stuff was not true. Okay. So, but what I think this is related to is not whether it's organically grown or conventionally grown, but what else do you think it's probably related to? Freshness, related to freshness. Whereas the organic co-op was getting things locally sourced nearby in Wisconsin, and this material was coming from California. So that freshness makes a big difference. Of course, if you look at fiber, there was not much of a difference, in part because fiber doesn't necessarily degrade during the shipping process, right? But vitamins can. We had to actually confirm this because we had to study it throughout the state of Minnesota, and we were going to go around and collect samples everywhere. But before we did that, we decided, well, we have to just check and see how fast vitamin C degrades after we take a sample. And you can see this is Mizuna, and this was held at 4 degrees Celsius, and this is vitamin C. And you can see it goes from 12 to nearly 0 after how many days? 7 to 8 days. So it's really rapid. So that means all that kale you're buying, potentially from California, okay, that you think you're putting in your smoothies and you're going to get all kinds of vitamin C from, the likelihood is high that you don't have much vitamin C in that kale, because it's probably about 7 days old. So what's happening? The industry is changing. You're starting to see vertical integration. This is a former student of mine. He started a farm. He started a restaurant and a garden center. And so he completely vertically integrates because people are interested in coming and eating vegetables that he produces himself from the farm. He even puts tables out with tablecloths among the cows, and people pay $60 to come eat among the cattle. So it's the craziest thing I've ever seen. But it just speaks to the interest that people have in wanting a stronger connection with the food that they grow. And we're starting to see completely new crops. What crop is this? You know? Amaranth. So chefs want this because it's attractive, it looks beautiful on a salad. So the price that you get for this is extremely high. There's a company in Milan, Ohio called the Chef's Garden. You guys should look it up because it's a cool place. It's old Farmer Bob was almost bankrupt. He was at the farmer's market, and a chef came up and said, I don't want to buy that bushel of zucchini, but if you give me a zucchini this big with a flower on it, I'll pay you $1 each. And so that began his business. So now he sells to high-end restaurants and ships as far as Hong Kong. So, and easily a millionaire. He's on. Well, you have other crops that we're growing now, wheat, grass, things that we never thought that we would grow, okay, for foods, proteins. So what's happening in the future as we move forward? So this is the other NRA, the National Restaurant Association, and this is their projections for 2020. So you can see these are what people are interested in. Number 1 trend, eco-friendly packaging. Number 2, plant-based proteins. Delivery-friendly menu items, healthy bowls. I don't even know what, scratch made. I was going to say that's scratch. Creativity with catering, revamped classic. If we go to produce, the number 1 produce item for 2020 that people are interested in is mushrooms. Mushrooms. Come back to that. New robs. There are many kinds of things other than broccoli, or in the broccoli family, that can be eaten. Callellini, baby cauliflower. So new shoots and sprouts, hop shoots and corn shoots. I didn't even know people ate those. Did you guys know people eat hop shoots and corn shoots?
Hop shoots are good.
Hop shoots are good? Okay. So I find this place a great place to go. If I were going to go into business, I would always look at the National Restaurant Association to look at what's selling and to try to decide my customer preferences. So if you go to a produce manager at any grocery store, they're going to see their single most important characteristic that they want is consistency. They want to get the same product every single week all year. It is their biggest complaint about any produce that comes in from California or that is shipped in locally. So this was from the Riverdale Whole Foods down here. Okay, I went in there to go get my salad mix, and this is what I saw. There was nothing on the shelves, and it said that salad supply shortage due to inclement weather. So in Salinas, California, they had inclement weather, and it basically wiped out all the Whole Foods salad that was available. There was nothing available on the shelves. And this was just January. This was January. So what's happening is that's causing companies like this to move in. Gotham Greens just bought a place up in Baltimore, and they're starting to produce in Baltimore. So it's a local producer of greens. So they're moving in to fill in that place or take that void. We're also looking at new techniques to grow things that are non-traditionally grown in these types of systems. What's this? It's actually radishes, but they're old and then they look like turnips. Okay, what I've done quite a bit of is that there really was amazingly little information on how to grow this stuff in greenhouses. You would think that we had this information. I had to go back and just try to get the basic information. So for instance, most greenhouses we light, well, how much light do you need? If you multiply these numbers times 5, you get the foot candles. So 400 micromole is 2,000 foot candles. But I put this picture up because I'm going to show you this company when I'm done, a video. But they were comparing Arroyo, which is the main romaine lettuce that you eat, okay, to a new variety, 16925. Now you can see the 16925, what's the first thing you notice about this crop compared to Arroyo? And this is in photosynthetic rate. Instead of being 20 as a maximum, it's 30 as a maximum. You get 50% more photosynthesis from the same plant. So how's lettuce sold? By weight. So you're going to get 50% faster. So we're starting to look at photosynthesis in controlled environments as a way to breed ways we haven't. These are tomatoes down at Bushel Boy, and each of these is a variety. And what this tells you is that every tomato variety actually should have a different lighting regime that's used for it. This one, which was a cherry tomato, took light all the way up to over 6,000 foot candles, whereas this one maxed out all the way down around 3,000 foot candles. So if you put the same light on all of them, you're wasting energy. We went ahead and did tests on all these different crops. Here's collards, sorrel, crispy cress, and we figured out the lighting requirements of all these, but we also figured out the CO2 concentration requirements and where they max out on carbon dioxide. So if we look at spinach and look to the far right, this is where the light saturated, where if you went over this amount, you didn't get any more growth. And so this is around 5,000 to 5,500 foot candles of light. And then above that, you can light all you want, but nothing's going to happen. Plant can't do any more. Okay? If I eat one Whopper, I might use it. If I eat 2 Whoppers, my body can't use it anymore, and so I just put on weight. But notice also down here with CO2, 743, 807, and 844, all of those are above ambient. Okay? So all of these crops benefit from the injection of CO2 as far as photosynthesis. When we looked at greens, we also found here 68 Fahrenheit, and you can see that most greens that we looked at, when you exceeded 68 degrees Fahrenheit, you actually decreased yield on fresh weight gain per day. That means if you're trying to grow greens in Maryland in the summer, they're going to do terrible. Your fresh weight gain per day is going to be down. This justifies growing greens inside with air conditioning, actually, and growing them cooler. Your gain per day, your yield per day actually is going to increase dramatically. In part, this is a type of we call them deep winter greenhouses in Minnesota. And so it's a concept we came up with. And frankly, all it is a lean-to, okay? But in some cases, I'll show you a picture a couple slides from now. We put on solar panels. Most of these have a rock bed that's 6 feet deep. The rock bed heats up and it radiates heat during the night. There is no fuel going into these. They're completely, there's no input other than that. So you would think the crops would not grow well with these things. So we compared conventional greenhouses in Minnesota, that's 1 through 6, with the deep winter greenhouses. And we collected data in all these. We put in data loggers and all these things. And remember that kale that I talked about that we wanted to drive around? We were going to drive around and get the kale here, 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 here. But we realized we can't do that because the time that we were driving, we're going to be reducing CO2. So we had to come up with a different system. So here's a conventional greenhouse. Stays between 75 and 50 degrees. The computer runs it, just like our fancy greenhouses down the road. And then this is what a deep winter greenhouse looks like. So here it's cold at night, and then you get these spikes. You can see some spikes up to 110 degrees Fahrenheit, quite warm. But what was interesting was this. The deep winter greenhouse, which was cool, okay, compared to the conventional greenhouse, actually had higher yield per day in fresh weight gain on all these crops. And this was with supplemental lighting. This one had no supplemental lighting, and mustard and spinach actually were as high as with supplemental lighting. So in this case, the supplemental lighting had no effect. But what's interesting is this. If I go to, let's say, kale, okay, or chard, and compare it to a conventional greenhouse with lights that's commonly grown now, all those greenhouses you see, is the fresh weight gain per day more or less than the warm greenhouse with lights? Less. So that means that many of the vegetable growers who are growing greens are actually spending money to lose money. Okay? It just really speaks to the fact that we don't really understand a lot of these crops. Also, we went ahead and calculated the photosynthetic gain, but we subtracted out respiration. So all of you are respiring now, right? How many calories do you need to live? 2,000, right? Most of you are around 2,000. You're respiring and you need that energy to keep your cells alive. Plants respire too. Well, you can actually back out and calculate things. And what we're starting to realize, if you look at Melody, and these are two kinds of spinach, you can see that Melody spinach has significantly higher photosynthetic rate. But by the time you back out the respiration, you can see that difference is even more accentuated because the respiration rate can be quite high with Bloomsdale. So we're actually thinking that people should also be breeding for a lower respiration rate on some of these greens in ways that they haven't done in the past. What's one of the things in your refrigerator that respires the most? It's being sold right now. There's lots of it in Whole Foods right now. Asparagus. She's good. She's getting all the right answers. Asparagus. Asparagus has a very high respiration rate. It's one of the reasons why it goes bad so fast if you leave it out, or it goes bad so fast even in the refrigerator. Kale, we go to kale, it's on here. Look at the respiration rate of winterborn kale, 0.4 compared to spinach, 5.2. Why does the spinach go bad in that mix that you buy so fast? It has a higher respiration rate than the kale. So lower respiration rate is going to keep things going longer. So this deep winter greenhouse, we have solar panels. The air, it actually blows fans down through tubes into the rock and heats the rock. And it's completely off the grid. And this is, you'd be amazed at how much you can produce food-wise from these things. So people are using these as a supplemental income source beside their normal job. Mushrooms, this is Mississippi mushrooms. I work with these guys. They're two former grad students in plant pathology that broke off from the university and quit and started their own mushroom business. And they're focusing on these unusual mushrooms that the restaurants want that they can't get. And so they're completely selling out of everything that they produce. So they're growing all this stuff in warehouses, and they're growing it in agreement with the park system, because one of the best media to grow these mushrooms on is green ash. And what's the problem right now all over the United States? Emerald ash borers. So we have supplemental green ash everywhere. So we're recycling the green ash into mushroom production. Questions on those things? Any? Green ash tree. It's a tree. There's a lot of them around here, and so it's a street tree that the emerald ash borer is attacking and killing all over the country. So we had to cut down 40,000 of them in Minneapolis.
Can you remind people remotely that you're also interested in their
Say again?
Can you give a reminder to the kind of people who are accessing remotely?
Oh,
that they
yes.
can certainly ask their questions.
Yes. So this is just a reminder that the people online, you can ask questions as well. I think I'll be flagged, and then they'll read me the question. Yep.
Okay, so there's obviously got to be some plants that don't work well with hydroponics. I was just kind of wondering, like, if there's any right temperature.
Yeah. So the biggest collapse or problem I would call would be spinach. And spinach, if we try to grow spinach in a warm environment, okay, it'll become disease susceptible, specifically to a disease called Pythium, and die. So disease plays a role in it. But as far as a hydroponic solution and something that cannot grow in a hydroponic solution, we've done everything from lettuce to cactus. Okay, yep.
The light intensities you mentioned for the peak respiration rate, how do they compare with sunlight? Is it higher than sunlight?
So full sun. Okay, the question is, how do the light intensities we did research with compared to sunlight? Full sun, okay, is going to be 10,000 foot candles, which is 2,000 micromole. So you saw we went up to, and they were leveling off in many cases, not at 2,000 micromole, but all the way down at 1,000 micromole, half of sunlight. So much of the light that plants get outside, they can't use. They're saturated, okay? Having said that, if I go out here on a cloudy day in the middle of winter, it'll be right around 300 to 400 micromoles. So 1,500 foot candles. So, you know, almost a tenth of what the plant, you know, in the middle of the summer. Okay, we'll get into nutritional value quick. I get into this because I thought, well, I wonder if I could make some sort of a super green that basically will substitute as a vitamin, right? What if you take a handful of greens and not take a vitamin? You know, can we do this? Can we really load up something so high in nutritional value that it works as a vitamin? So what I did is first thing I did is I tried to identify opportunity crops. So I went to the produce managers and restaurateur owners in the area and got them into a single room and said, what do you need that you can't get locally? Okay. So they said, believe it or not, that mescaline mix that we eat so much of, but also strawberries, spinach, kale, and cucumber. That's what they needed in large supplies. We also said large supplies, not just one tray, but enough to sustain a grower. We actually set up chambers that were set at 10, 15, 20, 25, 30. This is from 50 to 86 degrees Fahrenheit. And then what we did is every morning and every night, we moved the plants between all those chambers. So what you get is you get 25 different day-night temperature combinations all at once. It's a lot of work. It's terrible on your dating life because you make them come in and move plants. On dinner, move the plants. So then we get this data. So we have fresh weight data, okay? So we calculated all this as far as the fresh weight in grams. But what I was really interested in is going after nutritional data. And so we did a number of different attributes, and we replicated this in time. And then also we replicated this with the number of plants. So I'm in the process of trying to write this up. So we did find significant differences in CO2. This is kale, okay? And you can see CO2 levels peaked, were highest with actually a 59-day and a warmer night than day, okay? Oddly, iron increased whenever night temperature increased. If we looked at potassium, part per million per 100 grams, you can see it was highest with a high day temperature, an 86 day, and a cool night temperature. Then we were able to calculate, we did a crazy number of tissue tests, and we calculated what each of these different nutrients was associated with. When something is positively correlated, this is the correlation, that means that as day temperature went up, calcium went up. As night temperature went down, calcium went up, and so forth. Average daily temperatures here. Difference is the difference between day and night temperature here. So you can see when there's a high difference between day and night temperature, that iron, potassium, zinc went up. So then we started overlaying these things to see all the different nutrients, if there are areas or places where we could produce plants that would have extra high nutritional value. And we found that to be the case, especially with temperatures between 15 and 20 Celsius, which is 63 to 68 degrees Fahrenheit. We did other work where we looked at day length. So we looked at short days versus long days, an 8-hour day versus a 16-hour day. You would think that the one with the 16-hour day might have higher nutritional value. In the case of kale, however, red Russian kale, short days actually resulted in greater vitamin C content. We don't understand this, but we found this over and over again, suggesting that day length has an impact on the nutritional value of some of these crops as well. This is work by other folks where they simply looked at whether the EC of the solution, so this would be the hydroponic solution. So this shows you that as you increase the electrical conductivity of the hydroponic solution, you get the dark color, okay? So the dark color is the high EC, light color is low EC, and you can see that lycopene content was higher when you grew plants under high EC. Well, with a hydroponic system, you can adjust your EC to increase these things. And you also can do it at the end. So it's I'll come to that in a moment, but you can amazingly do some of these things the last 3 to 5 days and have a large impact on the fruit. We also looked at different kinds of media and equalized the media for electrical conductivity. Same fertility. Here's conventional media, and here was media where we leached with poultry litter, of all things, okay? but we measured the EC and kept the electrical conductivity the same. Everything was in the same greenhouse, the same media, the same lights, everything. But notice that the vitamin C content of Mizuna and red giant mustard went from 8 in this case up to over 20, and here it went from 4 to 16. I have no understanding why this happened, other than we made the media biologically active, because conventional media is sterilized. So we're replicating this in a capstone class that I'm doing in the department to see if we see this again. Questions on the nutrition stuff? Yep.
So when you change the electrical conductivity, is it the mineral content that is changing, or the charge changing? Is it the net positive and net negative?
Yeah. So in this case, what this is so the question is, when you change the electrical conductivity, are you changing the charge or anything else? No, you're just changing the total salt content. So you're increasing the total amount of, basically you're increasing the fertilizer. So this says that a higher fertilizer concentration was increasing the lycopene levels in tomato, higher than we expected.
Lycopene stress related?
It could be.
Yeah.
I'd ask the food scientist.
IEC.
Oh, the question is, is lycopene stress related, and could that be related to the fact that when you stress with a high EC, that would be the case? That's possible, because I'll tell you that I work with a company that raises the basil for Trader Joe's, and we found the increased basil flavor. A week before sales, we drought stress the plants, because herbs will often produce the essential oils that give the flavor to herbs in response to a stress. And drought stress is something that will work. If you grow the basil completely in hydroponic and never stress it, it'll be almost flavorless.
So I'm going to put on my media hat and ask you this question.
Your which hat? The media?
What's that?
The media hat?
In media hat.
Okay.
So most of the crop growth models, things like that you see is based on the yield, not for the nutrition. Right?
Based on the what?
It's based on the yield, right? So most of the crop growth models predict the yield, right? To change
Yes,
the variety,
yes.
to change the environment, things like that. But I'm not aware of any model that actually looks at the nutritional value. So if you want to increase the nutritional value, are there models that can predict? And then so you are showing the temperature, nighttime temperature, daytime temperature, this and that. Can we actually simulate all that in an equation or a model that, okay, if you want to grow, say, spinach with this nutritional quality, we need to have all these parameters reflected, and I can model it, and I can build a built environment that maximizes the nutrition. In addition to the yield, maximizes the nutritional value.
So the question is, and I'm repeating this for the online folks, the question is, can we make a model, or is there a model out there that models the nutritional value of these food crops, and could we make a model to do this? The answer is, I know of no model that has done that, and I think that's the next step, because even the specific nutrients you put in at the end of a crop differ during the life of the crop as far as the impact. And the light, which I'll show you in a second, the light quality or color you use at the end of the crop is important. Like you have to add red or blue light at the end of a red leaf lettuce crop to get red leaf lettuce. So the wonderful thing, Puneet, is that the new lights that are out there is literally, we can actually change the spectra within a day and over time with computer models. So I think that's the intersection with engineering that we need to have that doesn't exist. Okay, I'll be done by 7, don't worry. Okay, food safety. So one of the most important things, okay, with controlled environment agriculture is it's safer. And I absolutely believe it's safer. Why would I say it's safer? What problems have we had with lettuce in the United States? Where did it come from? E. coli, and it came from a place called Salinas in most cases. Well, I've been to Salinas, and what's in the fields in Salinas? Well, first of all, there's birds flying overhead, and they have wild hogs that come down out of the hills, and E. coli is in fecal matter of some of these species, and it gets on the leaves. In a greenhouse, there is no fecal matter. There's no introduction of bird dung. There's no introduction of these things. We're not sprinkling water that's recirculated out of a ditch that could have E. coli in it. Matter of fact, we sterilize the water with UV lights before it goes back onto the plants, but the foliage itself does not get wet because it's being watered from below. So it is safer. Okay, this is such a big issue, and I'll show you a picture after around 7-ish, that I helped design a greenhouse in Patterson, California, and it's a $32 million greenhouse, and it was built by Costco because Costco decided they were going to build their own greenhouse to get safe lettuce because they didn't want the problems that are happening in the industry. Something else we noticed was you look at nitrate levels. These are actually cucumber leaves, and the EU standard for nitrate levels is 3,000 parts per million. Why do people care about nitrate?
Nitrosamines.
Yeah, which cause what?
Carcinogen.
Cancer. Okay, cancer. Okay. So when we looked at these temperatures, we also checked to see what happened to the nitrate levels. And you can see when you had a high day and cool night, the nitrate levels were quite high. And in fact, when we checked the California lettuce, because the Salinas Valley has day temperatures like this, night temperatures like this, the nitrate levels exceeded the EU standard. So in some cases, we may be eating, or lettuce may be sold to us that have nitrate levels that exceed the EU standard. We also started doing some work on calcium. I'll just mention this. Calcium chloride in particular. We don't understand a lot of this, but calcium chloride sprays will inhibit pathogens, okay, especially botrytis, but also, in this case, on the lower graph, you'll see mesophilic bacteria. But we also get increases in growth with calcium chloride. And we're even using calcium chloride now in South America. When you buy those bouquets from South America that you get in the stores, they actually have been dipped in calcium chloride, then drip dry, and then shipped from Colombia to here because it inhibits botrytis on the exterior of the petals, the foliage. So it's greatly increased post-harvest life in cut flowers as well. Okay, last part is new technologies. We grow many of these things in containers. So here's Minnesota. This was, I think, 2 summers ago. The air temperature was 89 degrees, and look at the soil temperature, 54 degrees Celsius, which was 129 degrees. Okay, people don't think about the roots much. You can see that the root temperature in Minnesota, that doesn't count here, it's going to be worse, was getting up to around 130 degrees periodically. So here's tomatoes, which would be considered a warmer temperature loving crop. You can see they do quite well at 30 degrees, 35. You start seeing something happening, 40 something. The roots are dying. At 50 degrees, we actually are killing the roots. The industry actually, what's their response is, oh, I have root rot. So what do? Drench with fungicides like crazy, okay? So if we look at a graph of root dry mass gain, we can see that you have a peak around 86 degrees. And when you go over that, this is tomato again, it goes down dramatically and you have death at 122 in this case. Root temperatures are greatly underappreciated. So the stuff I talked about with spinach and warm temperatures, I believe that curve is shifted to the left and their maximum temperature is even lower. And that's why we can't grow spinach, which means that you could chill the water. So you could get around that by chilling the water. We're also looking at inoculation. So here's azospirillum. Here's the control. This is potato cutting. This work was done at Colorado State. We did work on this as well. And if you add these 2 bacteria, you can see dramatically more rooting. What's also interesting is that we worked with a person at what was Montana State. He's since left, Rusty Rodriguez, who was working with, he collected bacteria around the geysers at Yellowstone, and we were inoculating pots with these bacteria to see if we could increase the heat tolerance of the roots themselves. And we got some beneficial effect. So, but then my student left and I left, so we stopped. I gotta do that. Last couple areas that I think have a lot of potential is plant defenses. So if I go over to this gentleman and bite his leg, you'll know it. How will you know it? You'll see it and you'll hear it, right? Okay. Plants have no eyes, they have no smell. What do? They give off gas. So they will give off gas and tell other plants that they're being attacked. Okay, so here's volatile profile for undamaged allness. The people who are the farthest ahead in this whole area are the foresters. The foresters have been working in this area for a long time. This is the same allness but populated with beetles, and this is a gas chromatograph. So this is a profile of the gases that the leaf is giving off. Obviously, there's a huge difference between this and this. Something's happening. What's also interesting is here's a caterpillar, and if you tear the leaf with your hand, you don't get an ethylene response, but if the caterpillar is on there, we are getting the response. So down here is a wound and a wound plus FAC. FAC is actually a secretion from the caterpillar itself. So what does that mean? When the caterpillar eats or chews the leaf, the plant is actually perceiving the spit of the caterpillar and then having a response. Okay, I think this is the foundation for invasive species problems because you guys get a flu shot, right? Why do you get a flu shot? Well, you get a flu shot of something that's going to be similar to the actual pathogen to like prime your body to be able to recognize it. So when you do get it, your body can defend itself right away. If a plant has never seen that caterpillar or that pest, perhaps it doesn't perceive it. Therefore, it's defenseless. So I think a lot of these invasives that have not evolved with the species, the reason that they're so susceptible is because they've never seen it. What happens if you take away a plant's defenses? One of the plant defenses the plant makes is jasmonic acid. Here is a mutant where the plant can't make jasmonic acid. And look at the vitality of the hornworms on a plant without jasmonic acid versus with jasmonic acid. Clearly, there's a difference in the vigor of the caterpillar. Some work we did where we looked at increasing methyl jasmonate, which was a gas that stimulates jasmonic acid synthesis. What's methyl jasmonate a common component of? You know? Perfume. Okay? So when you walk past a plant and have perfume on, and there's jasmine oil in it, which is, okay, to the plant, you're encrusted with pests and aphids. Okay, so, okay. But what happens is the plant actually, in this case, this is an increase in protease inhibitors with methyl jasmonate. Protease inhibitors basically will give the insect indigestion. We think is part of the reason why these don't have indigestion and these do. So they have an upset stomach, they eat less. When we inoculated plants or exposed plants to methyl jasmonate and inoculated, all these plants had 8 aphids on them. And then after 11 days, we went back in and counted the aphid number. And you can see after 11 days, the aphid population increased, okay, which is normal. However, the plant that was exposed to methyl jasmonate for one night, okay, the aphid number was still the same. So we think this has the reason I bring it up is the greenhouse or controlled environment agriculture can use this that other parts of the industry cannot. Also, we exposed plants to aphid air or didn't expose them to aphid air and then released lacewings. What do lacewings attack? They're a beneficial insect that will lay an egg and the larvae will attack aphids. Where did they go? They went to the plant that was exposed to aphid air. Neither plant had aphids. If it had aphid air, it went and laid eggs. Okay, so either the lacewing has evolved to smell the smell that a plant gives off from aphids, or the plant somehow has evolved to call the beneficials to it. So we're looking at a different paradigm where instead of using pesticides, perhaps we should use attractants to attract beneficial to the hotspots. Last couple things, there's a large increase in phytopharmaceuticals. This is Hoodia. What was Hoodia? There's a whole thing on 60 Minutes with Hoodia. What's it do? Remember? It eliminates appetite. Huh?
Weight loss.
For weight loss. So Pfizer was interested in Hoodia for weight loss. The Bushmen in Southern Africa would eat Hoodia before they would have to run across desert and they wouldn't be able to get any food for 1 to 2 days. That's where Pfizer found this. We can grow Hoodia in greenhouses. And matter of fact, there's acres of hoodia being grown now. Mushrooms, of course, there are many, many mushrooms that have phytopharmaceutical abilities, right? Or psychedelic abilities, right? So, but most of them haven't been, no one's looked at them, you know, as far as the benefits that they have. The last things are fish, and just a couple things with controlled environment fish. So folks are not growing tilapia. Okay, they're focusing more on what you would have specialty fish that you could get a higher amount of money from the restaurants themselves. So this is that lettuce facility that I showed you in the very beginning. And so these are the fish underneath. So he's growing perch. We also started doing work on blue claws and shrimp. So blue claws is a Thai crayfish. Crayfish are great because they eat everything. The biggest limiting factor with aquaponic salmon is that the food that you have to use to feed the salmon, so it's decimating the anchovy populations off of the coast of Peru to make the pellets to sell to the aquaponics facilities in Scotland to get you that cheap salmon in the grocery store. But crayfish and shrimp in particular will eat almost everything. So you can use all kinds of plant waste. I haven't worked with oysters yet, but I think I'd like to try. The last thing is LED lighting. So this is a sea change that's allowing us to now do controlled environment ags and utilities. I wired it just a second ago, so hopefully it's right. Okay, so this is I'm not going to keep it on too long. So this is a light that I helped come up with. So I did this work with a company that makes those giant screens in screens. It's light. There's giant screens in NFL stadiums. Okay, so if you look at your TV, the old TVs used to have little pixels on it, right? And what colors were they? Red, blue, and green. Okay, so this is the same concept. Okay, but each one of these is a little LED, and what we can do is mix and match and change and make a profile. So I helped design this thing to maximize photosynthesis. So this is bright to your eyes. To the plant, this is like the sun. Okay. The other thing is it's flexible. Okay, you can pin it up or do whatever. So we're actually looking at applying this in places like NFL stadiums. You could literally roll out light in an enclosed stadium on top of the grass and grow grass where you couldn't grow grass before. We're also looking at putting it on the inside of cabinets in your kitchen. So your kitchen would look the same. You open up your cabinet and it would be a grow box. And then we also looked at changing the paradigm of homes where instead of 2 bedrooms and whatever, that you might have 2 bedrooms and a grow room. We couldn't do this before because we didn't have anything like this. They use almost, if you touch it, there's not heat. And so we can do things. So this is a system that we came up with, modular solar panel hooked up to a battery, hooked up to the LEDs and a charge back. So the idea was that you would put your panel on your roof, you buy it at Home Depot, it would charge a battery. When the battery was full, any excess would sell back. But in the meanwhile, when you grew the lettuce, you would be able to grow this. This easily grows lettuce in a basement, a lot of lettuce, one of these. But it's also going to change building design because now we can grow plants completely in places we couldn't grow them before. In this room, we could easily grow lettuce, for instance, without a problem. Okay, and I'm not going to get into all this. All I'll say is that this is with red light, and I'll just look at, let's say, dill, and we'll look at fructose content. It went from 4 to 10. Okay, and this is 3 days of red LED light at the end. Dramatically increased fructose content, and you'll see the other sugars as well. Also, we know that LED lighting, each of these are different bands of 200 nanometers. Each different color of light will impact different aspects of the phytonutrients within the plant themselves. And you can see clearly that certain colors of light promote ascorbic acid, which is associated with vitamin C. Also, if you compare this to down here, you can see this is the case also. Here's beta-carotene with mustard. Look at just adding red light at the end. I threw this up because this is the difference between open field planting and under glass. And this is tomatoes. And this is the lycopene content. And you can see outside significantly higher. What's the biggest difference between outdoor light and indoor light? Greenhouse, what's the biggest difference? Outdoor light includes what kind of light that's not inside? Yep, UV light. Okay, you can't get a suntan in a greenhouse. If we add UV light back, okay, here's so you can see that in this case, beta carotene went from 5 up to 20. So now we have the capability just within the last 2 years to make UV LEDs. So we're looking at putting UV LEDs in here. Related to pot, if you add any UV light to a pot facility, the THC content increases dramatically. Big effect. So with that, I'll just thank these folks, USDA, ARS, and all these other folks that help participate in the research that I have here. And this was the picture of the year a couple of years ago. And I thought, how long did it take them to get that picture? Yep. So why don't you show that one, show the Go Green.
Go Green?
So while he does that, I'm going to ask questions and I'll come back. So he's just going to go to just 2 websites to show you scales. So the first, not this, yeah, that one. So this is the place I was 2 weeks ago. This is the Costco facility I mentioned. So 2 engineers are actually the owners of this facility, and so they learned how to grow plants from people like me that go and help them. So this just opened. So this is called nutrient film technique, where it goes down a tube, but they design the packaging facilities. Something I would like them to do, and I've talked to them about, is on not this, not this, not this, but the mechanical packer, those, coming up with a rapid sensor for E. coli detection in that spot. So we have a faculty member in my department that I think may be able to do that. And so we're looking into that possibility. They've just doubled the size of this just 2 weeks ago when I was there. Yep.
If you want to do a field trip, we've got nutrient film, hydroponic grower, South Frederick.
Yep.
So it's right there. That
Yep.
you can, and they're very open to it. They're really becoming an AUMD collaborator.
So I went out there because the leadership team of Costco came. They flew their own plane in and landed. And so they're planning on building 5 of these. And so I helped build this one. So I was making the case that one of those new facilities should be located in Maryland. So can you put the other one on quick? Yep.
I was just really curious if you record like greenhouse gas emissions.
So the thing that,
Can you repeat the question?
yeah, so the question is, do we record greenhouse gas emissions? So what I can tell you is, what do plants take up? They take up CO2. I hate the term greenhouse gases because it insinuates that greenhouses produce carbon dioxide. They do the opposite. Greenhouses use carbon dioxide. We're actually helping the environment, not hurting it. So we do add CO2, but it's enclosed. But we have to add CO2. So we take waste CO2 from other people's facilities, like the, oh gosh, what do you call the corn people making the fuel? Ethanol. The ethanol folks have lots of excess CO2 they're trying to get rid of. They get tax credits for selling it. We take up the CO2 that other people give off and reuse it.
Why are so many people under the impression that greenhouses release so much carbon?
Because of that name. I hate that name. You know what releases all kinds of carbon dioxide and CO and methane is what? Cows. Cows, right? We're the good guys. Okay, we take up CO2, although we're giving it off right now. Humans give it off. So yeah, okay, can we go down? So I'm just only going to just show just a tiny piece of that. Yep, click on that and then expand that if it works. But if it doesn't, oh, it gets to play. So it's a place with a funny name. Great. Cute app. But then it gets cut. facility. Up the ramp, watt. Okay, so that's related to the food security issue. So now you diversify the distribution chain. So if we do have a major E. coli event in Salinas, okay, we're not going to be empty in our grocery stores. But it also increases the food safety. Now folks like Rohan can go right to a local place and make sure it's safe. So any other questions? Yep.
I just want to say like about like the stigma surrounding like greenhouses, like using like a lot of energy and emitting carbon dioxide.
Mhm.
Like, are they actually truly sustainable? Like the solar panels and everything, are they actually like not emitting carbon dioxide with all the energy with the heating and the lighting and everything, or is there negative?
So they use heat. They use heat. Okay, the question is a greenhouse sustainable? And the answer is yes. Okay, because we can have, like in cold climates, we can pull a thermal blanket across, like we're installing down in our greenhouses here, which reduces the heating cost 30%. But one of the reasons why the romaine lettuce producer is profitable, because what happens is they get the romaine lettuce, and the romaine lettuce harvested in the field, they have to tear off the outer layers of leaves and throw them away. Because it's all clean in the greenhouse, they take off those outer layers of leaves and quadruple wash them, and goes through the chopper, and that's where you get your chopped bags of romaine lettuce at Costco. So they actually get 68 cents for the heart and 68 cents for the chopped. So they're even more efficient. Yep.
So it just, a lot of these greenhouses were in colder environments where I feel like creating heat without actually using like heaters is much easier. But like greenhouses here in Maryland experience very, very hot summers, and I wonder, like, is there an efficient process to keep them cool?
The efficient process, so the answer is we have evaporative pads, but evaporative pads only work so far as you have evaporation. So when it's humid, they don't work. So in hot climates, what we're starting to look more and more at is completely interior growing now. And it used to be that wasn't affordable with high pressure sodium lights, but with these new lights and the amount of energy they use, it's now become something that we could do. And it may be cheaper than the greenhouse, because you can cool inside of an insulated building. I think there was someone over here. Yep.
I was gonna ask, do you, like, maybe in Minnesota, this would be a better, like, problem, like answer to a problem, but do you think in Maryland this, like, cost would be, like, compared to regularly, like, just growing lettuce?
So the question is this profitable in Maryland compared to just growing lettuce? Okay. So if I were growing in Maryland, okay, there's a whole group of crops that you can just grow outside during the growing season the way you normally do. But then there's a lot of parts of the year when it's not available because we can't grow it outside at that time. You know, I ate at, what's the name of that place? Woodbury Kitchen? Great place. So expensive, but good. But they're obviously willing to pay for local here. All those sprigs of rosemary and stuff they put in their drinks, the parsley, they're willing to pay a premium price to get it here. And one of the things I want to do is get all the restaurant folks together in Baltimore and then another group together in Washington to find out what they need that they can't get. You said a question too?
No, I have two questions. But I was wondering if any efforts are being made to make like these type of greenhouses accessible to third world countries, where nutritional value is like something really important.
Yeah, so I think there's a lot. The question is, in third world countries, is there interest in doing this? You know, this is pretty fancy, okay? But I was astonished, I got to tell you, when I went to Tanzania and stayed in a hut on top of a platform, and it had hot water and electricity, and it was through solar. They were ahead of anything that I'd come across in the United States. Solar can easily run these things, right? So in third world countries, I think there's a lot of opportunity with the new technology. We couldn't do it before, but now we can. Okay, and this is changing rapidly because the efficiency of the LEDs used to be 1.8 micromole per joule, and now this one is 2.5. Well, that's a big increase, and that was just in 3-4 years. So things are changing very rapidly. So I think the answer is yes. I think it actually increases food access in places that they couldn't, because they could grow inside where it's cooler, because in some places heat is the issue, and then light with this instead. Yep.
In a greenhouse like this one in the video, where you're growing all year, are there any major effects on the soil? Like, is there soil depletion going on, or how are they kind of resolving that?
So the media that they use, so you saw some soil here, and what that wasn't actually the soil, it was called core, which is coconut fiber, and it's recycled. So they sterilize it and reuse it. Yep.
Maybe they'd be interested to know that if they walk into Wegmans and a lot of other grocery stores, that the lettuce in clamshells is grown either Virginia or Maryland or Pennsylvania. So they are local. And so it is happening now, and they're all hydroponic systems.
The other thing is, after we came up with the nutritional data that for the greenhouse or the grocery stores, they didn't want to, I thought we were going to advertise it. They didn't want to advertise it because the problem is they can't get enough local product, and what they would actually be advertising is that most of their lettuce that they sell has lower nutritional level. You see what I'm saying? They can't get it, so that's the problem. So what Carol says is true. I'm sure the nutritional value is higher if someone, like I've been after farmers to just do a tissue test and show your stuff as twice the iron of something else and advertise that on your labeling. So, yep.
You showed a lot of these really good benefits that the environment can have. My question is the consumer able to taste the difference? Instead of growing in a greenhouse, instead of growing in an oven?
I think you can. The question is there a difference in taste between growing outside versus inside? And the answer right now is yes. Just like if you buy the strawberries that were grown outside or we grow here, they have that fragrance and that aroma. But I'll just mention the UV light. The UV light is associated with that flavor and aroma. So I think the new technology of putting UV back in, because it's the component we haven't had, is going to be a game changer with flavor. It's also going to increase something called the cuticle on a leaf, which is the waxy layer, which is likely going to increase the post-harvest life of the same products.
What are the ways that carbon dioxide is increased in the greenhouse?
Yep.
Like how they increase the concentration?
We used to use these burners. The question is, how do you get CO2 into the greenhouse? So we used to use CO2 burners where we burn fuel and it would give off CO2, okay? However, the problem with burners is if they have a problem, it's a very small amount of problem before you give off another gas called ethylene, which will cause all kinds of problems in the greenhouse. It's a plant growth regulator. So now what we're using is purified CO2 that's collected as an industrial waste product, and it's completely clean. So one tank will last a long time. Yep.
Is there a way to, like, is there any research about pairing carbon sequestration technology with greenhouses, like pulling carbon out of the atmosphere?
Yeah, there's one place in Southern California that's using the excess CO2 generated from their heater and then harvesting that and then using that to then use the CO2 during the day. So they capture it at night, then use it during the day when the plant needs it. Remember, the CO2 you only want during the day when the plant's photosynthesizing. Puneet?
So, I mean, if you think about it, the amount of engineering and technology that goes into having this automated system we just showed, it's probably not cost effective right now for lower value crops. Right? Do you think that it might become cost effective for low value crops as well in the future?
So what I've noticed is this, that the people just getting into the industry that want to, what they'll do is they'll serve the restaurant industry in a town. And so they'll, in one greenhouse, produce all different kinds of things at once. So they don't have the scale that you would need for this. So, but they need to get the price. So they're the ones doing the Amaranth and things like that that are really high-end things, or edible flowers, which a lot of restaurants want, that doesn't fit with this model. So this model works with large scale. Now, Amazon has an interest in, you would go online and click that you want a head of lettuce, and there'd be a camera on the robot that would go out to the grow facility adjacent to the distribution center, cut the head of lettuce, and you would watch it harvest your lettuce, and then it would be delivered to your house that afternoon. So that's where they want to go. Okay, so for lettuce and things that are large scale, Puneet, that makes a lot of sense. For small scale stuff, no. Yep.
Are there any benefits to field agriculture that you're having trouble replicating?
We don't know. So the question is, can we completely replicate field culture in a greenhouse? And so far the answer is no, because the plant takes up things we don't completely understand, something like related to what Puneet was talking about as far as nutritional content. There's an interaction between light intensity and UV. We don't understand that, but we're getting pretty close, because we didn't even have the UV lights to even research with until 2 years ago. And even then they were $500, so no one hardly had them. And now they're, I think, already down to 30 or 40 per LED. So yeah, so what we're doing is we're tuning these now so that there's LEDs, and so you can simulate sunrise, the middle of the day, and sunset. So you can even simulate a day. It will change with this thing instead of just being turned on or off. So we're learning, but we still don't know. Yep.
So something which struck me about the factors that influence growth and nutritional content seem to be nearly limitless and also sort of codependent in that they might interact with each other. Is there care being taken to implement almost like a modular design to things, or some way that these facilities can be changed to adapt to more recent findings as more research is done into the factors that are present with what development?
The answer is no, except if we had tunable lights, the answer would be yes, because then you could just change a computer program. Right? But with a fixed light, the answer is no. So, but that's why we're moving towards these tunable LED lights now. There's also UVA, B, and C. I'll just add, and I'll just tell you that UVB and C inhibit disease and also insect pests. And so there actually is potential to reduce pesticide use through the use of the correct light. There's someone else up here?
Just real quick, when you were talking about when plants are giving off the gas when they're under attack, like, are they like trying to signal someone, or?
You know, what's interesting is this. Okay, the question is when they're giving off the gas, are they trying to signal someone? I was going to do this with a faculty member who actually is coming here in April, Adrian Hegman. What we're doing is trying to concentrate gas after we infest a plant and put it on a plug that's then dissolvable, and then we dissolve the plug and run it through a GC, a gas chromatograph. I actually think what's happening is that if the plant has seen the pest before, that it actually is giving off a gas profile that's specific to the pest. In other words, I think plants have vocabulary. That's cool, right? I like that. Okay.
Do we have any other final questions from the audience?
No, requesting, we have none at the moment.
Okay. Thank you tons for coming. Appreciate it.